Hello class, this is a video tutorial on paying off loans, and in this video we'll be looking at calculating unknown regular repayments. So when taking a loan, we can calculate the regular payments if given all other variables. So let's get straight to it. Before we begin, we should always summarize all the key values that we need. For this, we need our principal, which is 10,000. The rate is going to be 0.06. It's 6% per annum, but because it's compounding monthly, we need to divide this by 12. So this will give us 0.005. For the monthly repayments, because it's monthly, and that's what we'll be calculating, I'm going to let that unknown value equal M. Continuing on, in order to calculate this, we need our N value. So 5 years, 12 months in each, N will equal to 60. So with these values in mind, we actually just treat this as we would a regular loan repayment. So first, we calculate the compound interest earned on the $10,000. 1 plus R would be 1.005 to the power of 60. And now we calculate the monthly payments. The first payment is M times 1.005 to the power of, not 60, 59, because we only begin paying the loan 1 month after it's been taken. The second payment is again the same value M, the same interest charged on it, but this time this will only receive 58 charges of interest. This pattern continues until we get to the 59th month, still paying the same M value. This will only receive 1 month of interest. In the 16th month, we just pay the value of the payment, M, without any interest. Summing all of that together, going from smallest to largest, it'll become M plus M outside of 1.005 plus all the way until the very last expression, power of 59. Factoring the value of M, we get 1 plus 1.005 plus all the way to the very end, which is to the power of 59. Once again, the inside here is a sum of a geometric sequence, with the first term being 1, the rate being 1.005, because it's this term divided by the previous, and the N values is going to be, well, there are 59 expressions of 1.005 plus the 1. Well, there's going to be 60 terms in here. Using the sum of a geometric sequence, we get 1 outside of 1.005 to the power of 60 minus 1 all over 0.005. In case you've forgotten, I'll write the sum here. that's what I was using. But now that we have both of these expressions, this one and this one, we can find the value of the loan at 60 months. It's going to be the compound interest here. Do this in blue, minus all the repayments plus interest. Now the next thing that we should understand is, because after 60 months the loan is to be repaid in 5 years, which is 60 months. This means that the value of this loan must be equal to 0 because it's been fully paid off. Now that we have this, we can now solve for m. The next step I'm going to be doing is be moving this entire expression to the other side of the equation, making it a plus along the way. So this will be that expression, now positive, is equal to $10,000 to the power of 60. Solving for m, I'll do this one at a time. It becomes m outside of 1.005 to the power of 60, take away 1. And all I'm doing is I'm multiplying this because that is a denominator. Using a calculator, I've got one right here. It's going to be 10,000 times 0.005. It's going to be 50 outside of 1.005 to the power of 60, dividing by this expression as a denominator like this. We solve for m. So m is equal to this expression divided by this expression here. Plugging all of that into a calculator, we will get the following. Let's hope that it took the input correctly. There we go. So this gives us $193.33, rounding up to the nearest whole cent. So that there's how we calculate the unknown value of m. Now that we have this, I'm going to show you a little shortcut that we can use to understand this from now on. 6 years times 12 is 72, so n equals 72 years. We can still get the expression 10,000 times 1.005 to the power of 72. We just do the very first payment, M1, m outside of 1.005 to the power of 71. It's always one less than the total value of the loan. And we skip right down to the very last one where it's just m. From here we can skip a whole bunch of steps because the value of the loan after 72 payments is this expression. Take away the m outside of, well, we've seen the rate already. It's going to be 1 outside of 1.005 to the power of 72 take away 1 all over 0.005. And hope you saw how we could utilize this first expression in order to quickly get the next one here without having to go through all that formula. Then we let this equal to 0, and then we continue solving as we normally would. Take this expression, we let that equal this expression here. Solving for m, we get m is equal to 50 outside of 1.005 to the power of 72 over 1.005 the power of 72 take away 1. So really all we changed are the values of the powers. So this becomes 72. This also becomes 72. So if we pay for longer, we only pay 165.73 cents per month if we pay it over 6 years rather than 5 years. So I hope that gave you an insight into calculating the unknown regular repayments of a loan repayment. Hope to see you in the next video. Best of luck.